Hi students. So now let's try to understand what is a torque is. So what is a torque is to understand that one. So most probably as in any of the notebook. So when we apply the force to the notebook to open the pages, so we always apply the force as further away from the hinges. So this is some kind of the hinge. We call it a pivot point about which that I'm going to apply the force to open the pages are. So this is the how I apply the force. So this force is depend how we at what angle we apply and how much the force that is applied. So if I apply the more force, it will open it more quickly. So and at what angle I apply. Usually we apply to the 90-degree, the angle that I apply to the 90-degree to the uh, radial vector. This is to understand this one. So what you can do is this is a notebook that I have it. So to demonstrate that, so this is a pivot point about this point. So this is a radial vector, the position of that where I'm applying the force. So if I'm applying the force here, so this is R value that is and where I'm applying the force. So I'm applying the force. So this is the force. So if you try to understand, this is the force value and this is R value. So from here to here. So the R is from here and I'm applying the force at this 90-degree to that. So what we do is to find out the torque, we multiply this with how much the force that I apply. But let's suppose that I apply the force to some angle. So then there is a different case that we have it and it become more harder. So if you apply the force more near to the pivot point. So if I apply the force here, so it will become more harder for me. Even you have a laptop, so you apply the force to the always to the maximum. So if you have to open the door, we apply the force to the at maximum distance that you can apply. To understand this, let's come to the screen. So this is the torque. So I'm playing this video. So to understand this one, what is a torque is?
तो किसी चीज को घुमाने में कितनी ताकत चाहिए वो दर्शाता
Torque is some kind how much the amount of the force you require to rotate something is.
है। ये लगने वाली फोर्स और रोटेशन एक्सिस से उस फोर्स की दूरी पे डिपेंड करता है। जैसे कि तुम दरवाजे को खोलते हुए अगर किनारे पे फोर्स लगाओ तो वो खुल जाता है, लेकिन उतना ही फोर्स अगर रोटेशन एक्सिस के पास लगाओ तो बात नहीं बनती।
Let's look into that. So this is the force. This is the F is the force that I'm showing. Right now it is 17 Newton. So for the easy calculation, let me make it the 10 Newton. So let's make it the 10 Newton. The thing is, this is a radial vector. So this is from the pivot point. This is the R distance. That is the radial vector. We have it. And then this is the force. Right now the force is acting at the 90-degree. Let me make it the 90-degree. So this is 90-degree. So if it is 90-degree, you had the torque formula is Fr sine theta. So right now R value is 10, F force is 10, and you apply the 90-degree to that one. So sine 90 is 1. So you had the torque value is the 100 Newton meter. Newton meter is the unit for the torque that we have it. So the point is, so let's suppose I increase the radial vector, means apply the less force to give the same amount of the torque. So you can apply that force as further away from the point. So as further the force value is that you apply to any other thing, so it is can give the more torque to you, the same amount of the force, giving the large torque. So if you seen it, any kind of the a nut opener also. So if you seen it, the arm of that we keep it as long or keep it more so that it will be easy for us to open that one because it provides the more torque to us. Angle also plays a very important role in that one. So this is the 90-degree that the right now the torque is applied. So as I change the angle, I am increasing the angle. Which angle you have to take it? Between the radial and the force and the tail between the both the vectors that we have to take this angle. So if I'm increasing the angle, just see of the R vector, we have to take it always perpendicular. So if I'm going to rotate this one, just see the perpendicular distance is decreasing every time as I increase the angle. So if I perfectly I make it degree means the force is toward the pivot point. There is a no torque. Almost the torque is zero. If you apply exactly at the 180 degree opposite to that one, so it becomes the zero that we have. So if it is 180, it is exactly towards the pivot point when you apply. Oh, it doesn't give you the any kind of the rotation. So if you try to understand, so if you have this notebook and apply the force to this one, it is not going to be, if you apply the force like this, it is not going to be open. So the book is, so if I apply the force like this, it is not going to be open. So you have to apply the force like this, then only it is going to be open. So then only it is, so it's very important at what angle we apply. So let's suppose I apply the more, so you can see if I apply the force here, so this is the angle theta, and then I'm going to change that the direction is. So if I make it again, so towards the, if it is towards the pivot point, again the torque is zero. If I apply the force away from that, so let's suppose like this, doesn't make any kind of the sense because it's not going to be open that the notebook is. So this is the thing that you have. If the angle is zero, again you have the G. So if you apply the force like this, so this is the perpendicular distance from the pivot point and how much the force that you are applying. So we take perpendicular distance from that. So if I demonstrate that one, let's try to understand what is a torque. Torque is equal to force R and the sine theta. Okay, let's try to understand the torque is. Torque is, we call it that the force into the R perpendicular force. We take the R perpendicular force. So to find out the R perpendicular, this is the theta that I taken the force, and this is the R radial vector direction is. And so this is theta, this is vertically opposite angle. So I have to find out this R perpendicular because that is the, we always take the position that is perpendicular to that. So this is R perpendicular that I have it. So, and to find out this one, this is R value. So this is a right angle triangle. If you see it carefully, this is a right angle triangle. Let me name it OAB. So this is a right angle triangle. So if this is the opposite side. So to find out the R perpendicular, I have to apply sine theta. So let me write it the sine theta value here. Sine theta is equal to R perpendicular and how much the R it is. So R perpendicular, the perpendicular direction is come out to be R sine theta. So basically, so the torque value R perpendicular come out to be R sine theta. That is the perpendicular distance that we have. So the torque formula is actually, we use it R F R sine theta, and the theta is the angle between the vector, this vector. So this is the theta is angle between the force vector and the radial vector that is shown away from the pivot point. This is the theta that I'm going to take it right now. And between the two tail, you can understand like this, the angle between the two tail. So this is the whole idea that we have. So if you see it carefully, if I apply the different angles, so you can see this one. If I apply the different angles, the perpendicular distance is changing every time. If I make the theta is 0, so the sine theta becomes 0, so the torque becomes 0 at this point. So as I'm changing, so as you can see this one 90 and this is the perpendicular direction. This is how it is changing at every point. So other way to do that one is you can split the force component. So this is the force that is acting right now. So you can find out the force perpendicular, this F cos theta component. This is the F sine theta. So if you try to understand this component that is acting along the pivot point, this force. So if you think it logically, if this something have to be rotate about this point or something this point, and you are applying the force like this to this one, so it is not going to be rotate. So you had to be apply the torque is due to the only due to the force component that is perpendicular. Even you can think like this, because the torque is equal to, before I written the force F R sine theta, correct? So this sine theta component, you can take the component of the force also with that. So this is R. So this is F sine theta, means the I have taken the component of the force. Instead of finding out R perpendicular every time, sometimes it's easy to find out the F per component of the force that is perpendicular to the radial. So if this is the R value, so it's easy for me to find out this perpendicular force value. So this is component of the force in the perpendicular direction. It's easy for us. So we sometime we find it out that one also. So I'm providing this animation to you also, so you can play with that one. I will attach the link of that. Thank you for watching. So if you have any of the doubt, please leave the comment and let's try to make the next video on your doubts that we have it. Thank you.